So we have already seen how the placement strategies FirstFit, BestFit and the WorstFit behave with fixed partitioning scheme. Now let's see how do these placement strategies work with dynamic partitioning scheme. So in dynamic partitioning, a portion of the main memory is reserved for the operating system and the remaining memory is considered as one big hall, and based on the process request, we will create a partition which is equal to the size of the process request and allocate that partition for the process. So suppose we have one request P1 of 100 bytes, so we created a partition for it. Next we have a process P2 of 50 bytes, we created a partition for it. Next process is P3 of 200 bytes, and assume the remaining memory here is 400 bytes. Now suppose that the process P2 has finished its execution or is swapped out of the main memory. Then this portion of the memory is deallocated and this partition will become free. Hence, as the process goes on, there will be a set of partitions within the main memory, of which some are allocated and some are unallocated. And then when we have a new process request, here we have a process request P4 of 20 bytes. Then we have two halls here. One hall is of 50 bytes and the other hall is of 400 bytes. Both the halls are large enough to hold this process. Then which hall should be allocated for this process? From the set of halls which are available in the main memory, we should select the hall for this process such that it works with more efficiency. So here comes the need of the placement strategies or the placement algorithms. So first of all, let's see how do the FirstFit strategy work with dynamic partitioning scheme. So in the main memory we have two halls. One hall is of size 20 bytes and the other hall is of size 400 bytes. Suppose we have one process request P4 of size 100 bytes. Then in the FirstFit strategy, we will select the first partition which is large enough to hold this process. So here the first partition is this one, but the size is only 20 bytes and this one is not large enough to hold the process. Hence the next partition is this one, which is free and the size is 400 bytes, and this partition can hold the process. It's large enough to hold the process, so we will select this hall for the process. Thus the process P4 occupies this partition, leaving a memory space of 300 bytes. Now assume the next process request is P5 of 10 bytes. Then according to FirstFit strategy, we should select the first partition which is large enough to hold the process. So the first partition is this one, the size is 20 bytes and this one is large enough to hold the process. So we will allocate the process to this hall. And the advantage of the FirstFit strategy is that it is fast, because suppose we are using the linked list implementation for this dynamic partitioning scheme, then to find the first hall which is large enough to hold the process, in most cases we need not search the entire linked list, because we are going for the first partition which can hold the process. So the search time is reduced, hence the FirstFit algorithm shows a fast behavior. Next, let's see how do the BestFit strategy works. In the BestFit strategy, we will select the partition, the smallest partition which is large enough to hold the process. So in this case, which is the smallest partition? This is the smallest partition of sizes 20 bytes and it is capable of holding the process. This one is large enough to hold the process. So the smallest partition which is large enough to hold the process is selected. So here we will allocate the process to this partition. And in BestFit strategy, to find the smallest fitting partition from among the set of all partitions available, we need to search the entire list to find the proper hall according to BestFit strategy. Hence, the search time is more compared to the FirstFit strategy. Hence, the one disadvantage of BestFit strategy is it is slow, and the second disadvantage is that, see here, this hall size is 20 bytes and the allocated process is of size 15 bytes. So here we have left a memory space of 5 bytes, which is very small. So if we go for the smallest fitting partition, it will always leave a small memory space. A small memory space will always be left behind, and there is least chance that the new coming processes will get fit into the smallest partition. So the BestFit strategy will lead to small memory wastages all over the main memory. Hence, it increases the chance of external fragmentation. This is one limitation of BestFit strategy. And the second one is it has slow performance. Next, we shall see how the WorstFit strategy work. In the WorstFit strategy, we will select the largest partition which can hold the process. So in this case, here there are two partitions which are free. The largest one is 400 bytes, which can hold the process request P4 of 15 bytes. So the process P4 will be allocated here. And in case of WorstFit strategy, similar to the BestFit strategy, to find this largest partition, we have to search through the entire list to find the proper hall according to the WorstFit strategy. So the search time is again high compared to the FirstFit strategy. But unlike the BestFit strategy, since here we are going for the largest partition, the leftover memory space will be large. So there is more chance that the coming new processes will get fit into this partition. So we will be able to reuse this leftover memory space. So the chance for external fragmentation is very less compared to that of the BestFit strategy, but the search time is high compared to the FirstFit strategy.